US version of it. I've heard so many people call it Leicester. That makes me cringe.
We're not good at this.
No.
All right. I'm going to get started because why not at this point? Okay. Normally apologies for all the technical difficulties, everybody. We'll get started here in 3. Hello, everyone. Thank you for joining us. Sorry, we were a skosh late there. My name is AJ Kuftic, and I'm with Expedient. Today with me is Neil Stobart from Cloudian, and we are going to talk about the object storage epiphany. Real quick housekeeping note, though. If you have any questions, please enter those into the Q&A panel about here. That helps us keep track of them. Neil is here to answer all of your object storage questions. I'm here to answer some of your object storage questions. Along with any of your questions about Expedient. We'll answer those after the demo and the whiteboarding, so that should be pretty fun. This is all being recorded. You'll get a link to the recording in your email afterwards. It'll also be available on our website, go.expedient.com/webinar replays, Instagram.com/_expedient, YouTube.com/expedient, and Instagram.com/ LinkedIn.com/company/expedient. We'll figure it all out. Go ahead and give us a like and follow on all those socials too. It really helps us out. For those of you who are new to Expedient, we started in 2001. We started in co-location and being an ISP. But over time, we've evolved our services. In 2007, we released virtual co-location to provide virtual hosting for our customers. This started the same time as Amazon EC2. In 2015, we released push button DR to do DR as a service. And today we have the fastest failover in the industry with transparent network failover. In 2018, we released our enterprise cloud to provide a full cloud operating model for all your VMware workloads without all the refactoring, again, helping you accelerate your cloud journey. In 2020, we released our cloud native platform, which object storage definitely plays a large part into, that provides fully managed Kubernetes application observability, persistent container storage, along with the aforementioned object storage. And this year, we've been focusing a lot on multi-cloud. And multi-cloud brings in a number of different things, specifically the hyperscale cloud world. And a lot of what the hyperscale cloud world has done over the years is made these big changes to the way that we do things. And the big one that we want to talk about today is object storage. And with me is Neil Stobart from Cloudian. Hi, Neil.
Hey, AJ. Hello, everybody.
So, Neil, let's kind of talk through, what really is object storage. Cloudian is a company that does that provides an object storage platform, but on-prem. So, Neil, for those who don't exactly know what object storage is, they've just kind of heard of it. What is object storage?
Well, it's an answer to the problem of scaling your data storage platform. Traditionally, as this sort of consolidated storage platforms have been brought to market, they've got to be bigger, they've got to be faster, they've got to contain more storage. And ultimately, the legacy architectures of the likes of NAS and SAN technologies, they've kind of reached to the point where it's not really possible to go any further, although there are some people doing scale out file architectures, but that's actually quite difficult, especially when you're doing locking between multi-site, even just between multiple nodes can be difficult. So in essence, object storage, I think, was kind of born in the cloud. It was born for these mega service providers, and we all know who I'm talking about here, but for them to be able to cope with millions of customers storing data, they wanted a centralized storage platform, one thing to manage, one thing to worry about, but for it to have multi-tenancy capabilities and just to be able to scale to enormous levels. So Cloudian, we kind of took a lot of that technology, like a lot of other cloud technology. I mean, if you look at the whole sort of compute orchestration side, again, that was born in the cloud. We wanted to do self-service, for creating virtual machines or some compute platforms. And it's the same with the storage piece. And as I was seeing the orchestration, that service level approach to IT, come down into the enterprise space, we're dragging that that cloud storage technology, down into the data center or up into the data center. So I don't know if you've got them. I've got a few slides here that really sort of just distinguish one of the key differentiators, what's different between object storage and traditional storage. So when I talk about traditional storage, I'm talking about, your traditional SAN and NAS storage arrays. So, this is technology I've worked with for the last 20, 25 years or something. So I'm not saying that there's anything wrong with this approach. I think it's about putting the right storage platform, for the right data set, for the right use case. So object storage is not designed for, dealing with, very small IOs. Like, if you've got a database, OLTP database like Oracle, or, some of the scale out like Cassandra, we're not designed for processing lots of small transactions very, very quickly. That would be where I would say, that's a block storage system, maybe a NAS, typically on sort of flash storage these days, because flash gives you, more IOPS for your dollar, but obviously hard drives give you more capacity for your dollar. So it's about mixing and matching those two technologies in the right place. So the traditional storage architecture is what we kind of call scale up storage. So the idea is you'd kind of have sort of two controllers that were resilient, and then you could add disk shelves, into that storage array, and then you could scale it up. I mean, you might be able to start with one disk shelf, and you could maybe scale up to 10 or 20, depending on the storage model that you have. So typically, the amount of disk drives you can attach is going to be limited by the number of IO ports you've got in the storage controllers. So it makes sense if you can only get 4 IO connections, you can only run, and I'm going to embarrass myself now, it used to be 96 devices on a SAS chain. It might be more now with SAS 6, but I can't.
I mean, honestly, from a technology standpoint, there are hardware limitations to the amount of...
There's hardware. So essentially, you're limited to the number of disks you can put in a system. Right. And then, if you need more storage, you need to put an entirely new system, and then you end up with system bloat. You're trying to work out where your data is. You've got multiple, no single namespace. You're going to sort of...
If we could get a quick show of hands in real life, if this were a real life thing and not a webinar, you would see a whole lot of hands of when I say, hey, how many of you have had to migrate data between arrays for capacity reasons? Everybody's hands in the room would go up. I've done too many of them. So these are the sorts of things, I think, you're limited in terms of you can't scale it out. You can't make it one contiguous platform. You get to a certain point and then, okay, now I need another one. And now you have to care and feed and maintain that as well.
So there's the physical aspect of it, but there's also the addressable storage aspect of it as well. So typically every one of these storage systems has some sort of storage virtualization going on, where they're sort of, bringing all RAID groups and disks together to kind of provide, services on top of. Now that virtualization database, it will be limited by, typically the capability, the processing power of the storage controllers, the size of the RAM available, but ultimately it's limited. And also, with file systems, you've got the limitation of the inode table as well. How, where is the map between the blocks on disk to the actual data being stored? So scale out storage takes a different approach. It uses sort of standard, more server-like building blocks rather than trays of disks and just regular servers for the controllers. It takes a server that typically is architected to have, dense storage, lots of, as much disk in there as possible. So now I think a lot of vendors are offering, at least 90, 3.5-inch disk drives, in some of their, very high-end dense storage servers. Mm-hmm. And what we do is we use that as the building block, and we then build out the storage cluster. So every time we add another node into the cluster, we get more CPU, we get more memory, we get more storage availability. And by consequence, we also get better performance because we're adding in more resources. And every single one of those nodes in the cluster is essentially part of the virtual cluster. So they're all available there, ready to get used. So this way we're getting around the limitations of the hardware, because now it's almost like that scale up platform is almost that's our base building block. The other piece is this addressable space. Now we've taken a very scalable distributed database, and we distribute all of the metadata database across all of the nodes. So that means that we know that if we go to any node, we can track where any data is. And not only am I just talking about a cluster in a single data center, this can spread over. At the moment, I think we support up to 20 data centers in a region. But you add up the nodes, we can support about 4,000 nodes in a single namespace, which if you add up, when I've taken the example of 90 drives in a server, it's nearly 200,000 hard disk drives in a single cluster.
Basically,
So,
it's more than you're probably going to use.
well, it's more than most people are going to use. I mean, we've got a number of conversations going on with, some extremely large customers who are asking for exabytes in a single namespace, which is mind blowing. It's
right.
mind blowing.
And I think that's the thing here, is that we're talking about new bytes. We haven't talked about things higher than terabytes in a very long time. Sometimes people talk about petabytes, but we haven't talked about exabytes of storage in a real honest fashion versus some sort of like marketing pitch that says all of these customers combined form like 1 exabyte or whatever of storage. There's one customer saying, yeah, we could probably use an exabyte.
There's a Japanese car manufacturer, and they're planning for the autonomous car and all of the telemetry that comes, all that information that comes out of the car. And I think they've got something like a 250-point check that the computers are sort of checking for, and they think that they would consume an exabyte of storage in 1 year. 1 year.
That's wild.
So if we can get them as a customer, then I think we can happily retire. And
I think that's that key piece that you mentioned about the multiple data centers is also really, really powerful, because your traditional storage array, traditional scale-up storage, that's one physical location.
Yeah.
It's very difficult to put that across multiple data centers without needing dark fiber, which means you're not going terribly far away. Trying to do all of that is very, very hard. And this makes it super easy. So how do we protect that data, right? Because I mean, I'll be the old man here, and I'll say that traditionally we've used RAID, and if a drive fails, it rebuilds onto other things. So how does that actually work?
Yeah, I think if you slip, is it the next slide? Oh, look at that! It's almost as if we rehearsed this, isn't it?
It's almost as if that was a segue.
So yeah, we do. So if you think about RAID, that terminology is redundant array of inexpensive disks, I think was the original thing. Now it's I think they changed it at some point, and we deploy something called RAIN, which is redundant array of inexpensive. I'm sure it's something else. Nodes. So we're essentially changing the lowest building block from a disk to a node. So now what we want to do is we want to protect against node failure and also data center failure, as people have been doing in the past. So typically what you would have with RAID, it's relatively, it's not very flexible. You can kind of do mirroring, you can do RAID 5, RAID 6. If you have a drive fail, you've got to rebuild the whole drive, even if that drive is got a lot of empty space on. It does. I think it's the right technology in the right place again, but erasure coding is something that we use, and it takes its concept from RAID, and the fact that it's going to take some data object and is going to create some recovery parity points, but they're going to be located on different servers rather than just different disks. But we have the flexibility to do kind of any combination of data and parity combination. We say it's K plus M. So a K is your number of data fragments, and M is your number of parity fragments. And we can do any mixture of them. So, we can do a 3 plus 2, we can do a 5 plus 4, we can do a 20 plus 5 if you really wanted to. But obviously you'd need as many nodes, to support that particular data protection as a minimum to start off with. Now, when we move to disaster recovery, we can kind of do just like with traditional storage arrays. You've got a RAID 5 storage array as your primary, you've got your RAID 5 storage array as your secondary, and you do some sort of replication over the top. So you're making a copy of data from, location 1 to location 2. And of course, you can do synchronous or asynchronous, or you can do it based upon snapshots. Lots of different ways you can do data replication. Where for us, we kind of present to the consumer of the storage, we present something called an S3 bucket, and that essentially kind of picks a its primary, or you decide which one's your primary DC, and it's kind of doing the same thing in the background as doing sync or async type replication between sites. But because it's hidden behind the bucket, if a site fails, it will seamlessly fail over. So in fact, there's no failover. It'll just seamlessly repoint you to where your data lives. So in Germany, for example, I would argue that NetApp have been the best storage company in that market, purely because the Germans love to have multiple, no single point of failures across data centers. And the only company that could really effectively deliver, business continuity between two sites was NetApp, with a kind of a Frankenstein solution that they had called Metro Cluster. We're doing great guns in Germany because we just hit this need so well. So there's no sort of disaster recovery planning, really. It's just, it is just fail over automatically. Now, there are considerations. You need to think how, if you're using asynchronous replication, there might be data that's not caught up over time. So you have to kind of accept at some point your recovery point objective maybe not being 0, but you can do that with sync replication. So you got the choice of what you do for your different data.
But I think the interesting point is that there's no manual effort. You don't have to point
manual effort for recovery, no.
Site. You just you continue to connect to your S3 bucket, and there's like a little blip that says, hey, wait, everything that was here now needs to go over here, but it all happens in the background seamlessly to the end user. So how are these end users actually accessing this? Because I think that's kind of the bigger challenge.
Yeah, so I'm hoping that the next slide is the S3 API one. Brilliant. So this again it's a key differentiator, or has been a key differentiator. I do see some of the solutions starting to bring in S3 API support, like some file system platforms. But the S3 API is not strictly a storage protocol like NFS or SMB or iSCSI or Fiber Channel. They typically, just read or write data to a storage medium. It doesn't really do anything else. I mean, a file system can collect some, what we would call system metadata. So some metadata about, your data file, maybe who created it, when it was created, when it was last accessed, size, file name, that sort of thing. That's great. There's some intelligence you can manipulate there at a rudimentary level. But I think now, we all know how important data is to every application, every user, every business, every organization. The S3 API, it allows application developers to bring in much more extensive data management capabilities. So they can add to their application not only the ability to read and write data from a storage platform, but actually to do a whole bunch of other stuff as well. So I've got some bits there, and my little graphic that I drew, with the, you can encrypt the application can encrypt the data. It can monitor where the data is. It can send a notification out once you've written data, maybe to another application to say, do something else with this now. You can put a time limit on how long that data lasts. Something that we'll talk about in more detail is worm. So from the application, it can set worm capability, so a mutable capability from the application, and the application can say, how long do I want that retention time to be? So it's this granular level of control that application developers can build into their systems. And on the bottom there, we can see that they're all data management platforms. They were very quick to adopt the S3 API. So the backup vendors like Veeam, Rubrik, Commvault, Veritas, very quickly they introduced S3 support, because mainly a lot of their customers were asking them to support AWS in S3 storage in AWS, very, very popular cloud platform. But now S3 has seriously become the de facto standard. So when I started out at Cloudian about 6 years ago, I would argue that a lot of our competitors some of them were focused on the Swift API that came out of the OpenStack world. There was some standards. A lot of the companies were developing their own proprietary APIs. And that held object storage back for a long time, because the likes of Veeam and Rubrik and Veritas didn't want to have to write 10 different connectors, to support all of these different object storage platforms. So the fact that S3 came along and got adopted as it did, I think we've got a lot to sort of thank AWS for, because it really is, a very powerful capability. So all of that sort of functionality is buried in the application. And as it comes to the S3 object storage, we're taking instruction from the application, what we're going to do with that data. Now, all of that management capability is built into our system as well. So if you have an application, for example, that doesn't support object lock, we can kind of use that technology there as well. But that's the real power of it. And I think as we get into that DevOps world where more people are developing in the containerized world, they've been using S3 API to, control and manage their data, which gives them, a better application in many extents. So it's slightly different, but it was also designed specifically to work over the internet. So if we look at SMB and NFS, that wasn't really designed to work over the internet. That was designed to work within a local LAN. And hey, you know what? What's the world we live in today? It's everyone's working from home. So is SMB, NFS good enough for us? S3 really gives us a much better way to share and access data, not only from applications, but also from users. It kind of gives you that Dropbox capability that people do like.
Right. So I see a lot of different data protection platforms here. I see Rubrik Veeam, I see Commvault. So let's kind of talk about how Object fits into backups. And in order to do that, we're going to use the technology and the magic of the internet. This is our whiteboard that Neil and I can both draw on. How great is that?
We'll see.
We'll see if Neil can do it. Otherwise, I'll be doing all the drawing. But I have the ability to draw here in the United States. Neil is joining us from the UK. So Neil and I are going to whiteboard across the internet, right? We just talked about how S3 makes things possible across the internet. We need to draw that. There we go.
Can you see me?
Can I see you?
No.
I think so. Yes, I see you in there. I see you. We're good. I see you. You should be able to draw. So we're going to start with the concept called 3, 2, 1 backups. Now, Neil, how familiar are you with 3, 2, 1 backups?
Pretty familiar.
I would hope so. So let's talk about what 3, 2, 1 backups really align to, right? It starts with some servers, right? And these servers switch our primary storage, right? In the concept of 3, 2, 1 backups, you have 3 copies of your data, 2 local, 1 offsite, right? 3, 2, 1. And the challenge is that before we have our primary storage, right? This is servers, maybe this is hyperconverged, maybe this is block storage, maybe this is even, some sort of object on-prem, but it's primary storage located on-prem, right? So we're going to put on-prem. I'm trying to write on a very tiny screen. It's much bigger up here. So the problem is that we kind of run into some challenges around things that we use to do those backups. The first is tape. And doing a backup to tape was great for a very long time because it fulfilled the needs. It gave me the ability to have an offsite copy that went somewhere, but it also gave me the capability to keep things very, very inexpensive because tapes individually seem fairly expensive, but they're not. They are very cheap and very deep in terms of storage and cost, right? The problem with tape is that once it goes off site, like say, I don't know, didn't click there. If I do this and I take my tape off site, I now have a problem. This tape going off site means someone has to go get it. If I have a problem, I need something to be recovered from this offsite backup. I can't do that. Somebody has to go get it. And the entire time that's happening, I'm sitting there twiddling my thumbs. That's not great. So how do we attempt to solve this? We attempted to solve this with disk. And this disk was pretty great because it is super fast, but it also costs many, many dollars, pounds, euros, depending on your locale. And because I have this disk and I need to replicate it offsite, I now need to have another disk. Guess what? Replicating this offsite is more dollars. Heck, I'll even throw some pounds in there, right? All of these things cost a lot of money. Hopefully you never have to use them, but they cost a lot of money to exist offsite. So how do we actually fix that? Well, we add in our nice object storage. And by being able to put a bucket here, let's just tilt my bucket so it's nice and sitting straight up, I have a very cheap, but also very fast recovery platform so that my backups can come directly over here into object and I can recover faster. I get my copy that's offsite, but I also have the capability to have all the things that I need at a good cost point that's fast to recover from. And Neil, this is one of the big use cases that you've seen. Neil's moving a tape, right? Neil's going to put that tape in the bucket. Just put the tape in the bucket. So the overall concept here is that these buckets have the ability to have all of this storage offsite, but not make it so that it's completely unavailable. And Neil, I think that kind of plays back into why all of these backup vendors focused on getting things into S3, right?
Yeah, so it's giving, essentially it's giving you that air-gapped storage. It's giving you, good data protection. And until recently, tape was the only game in town for worm. There was some storage platforms would offer some rudimentary worm capability, but it was either, locking the whole volume or locking the whole storage system. And then, that's not so good because that's expensive, because if you just lock that storage system for the next 7 years, and maybe your compliance reasons are longer, you're really locked in. So tape was always good because, one, it was portable and you could get it offsite, and two, it was considered, worm. But that was 20 years ago. And now
maybe less for some companies. We see you out there.
Yeah, well, I was doing a lot of tape. Used to do a lot of big tape implementations. Some of the big powder horn libraries. So that was what I was doing 20 years ago. But then there wasn't so much data, and cramming it. Tapes have got bigger, but it's just become more complicated. And I think with compliance, putting data on tape and making it portable, it's become a bit of a no-no, especially with some of the, in Europe, we have the GDPR privacy compliance regulations now. You've got to be very, very careful. You've got to really protect your data. So tape has become, I don't know, I still think maybe for a long-term archive, tape is viable, but the reality is that people need to be able to recover very, very quickly these days, because everybody's running in a 24/7 arena. We don't have the luxury of a 12-hour backup window where everything goes offline anymore. It's we're going to get the backup done as quickly as possible, but we're going to recover even faster. So having your backup data on disk obviously gives you that capability. And I know with even most of the modern backup applications, they can actually get you up and running without having to do a restore. They can get their services back up and going on the secondary storage media, whilst they're then recovering the data and flip over, as quickly as possible back when they're running. So, you can get data access almost instantaneously from a disk-based backup platform. And
I think the other key thing here to consider is that the big part here is cloud.
Yeah.
Right? And from a cloud standpoint, one of the challenges, and there is a question in there about recovery, is that when this data comes back, you get the lovely opportunity to pay for those egress fees. And that's actually one of the big challenges that a lot of people find out when this is actually the famous story of NASA, right? NASA put 250 petabytes of storage into AWS S3 because they're like, cool, 250 petabytes, that's cheap and we're done. Oh, wait, we got to get it back out. Oh no, that's going to cost us literally a moon trip. Yeah. So I think these are the sorts of things to consider which is why when we built our object storage platform based on Cloudian, we do not have any of the egress fees, and we don't have any of the operations fees, so that as you're doing puts and gets and you're recovering things back onto on-prem, you're only paying for the storage, you're not paying for those egress fees. So this is not your problem. And I think that's a key differentiator for us versus any of the other object storage platforms that exist out there, is that we can do all of the same object benefits, but without any of the big drawbacks from some of the hyperscale providers. And that's, again, powered by the Cloudian Hyperstore platform, which has been really, really fantastic for us. And we have customers who are doing backup archives, that one offsite copy with many, many terabytes of storage landing on our platform. So it's been really, really successful for us and successful for our clients. So Neil, why are backups important? Other than the fact that you got to save your beans from time to time?
Why are backups important? That was a lesson I was just teaching my son this morning when he came to me with his external USB drive and said he'd lost all his music he'd made last week.
No!
He's an idiot.
You just said that to people.
Says me who hasn't backed up my laptop for 6 months, and you can't throw stones when you live in a glass house. Why is it important? I mean, it's important as keeping your business alive. It's as simple as that. I think there's a lot of organizations that never recover if they have, an IT crash and they lose data and they can't get it back from backup. They never recover. They fail as a business. And I've seen that happen. It's life. So I mean, it's critical as that, and it's not even. I mean, if you take it into a wider social context, it depends on what data you're storing. Because if you're storing health data, if you're storing data about
payments,
well, everything, right? It's look at the ransomware attack on the Colonial Pipeline organization. I saw that on the UK TV. The chaos at a lot of the petrol stations. What do you call it? Gas stations.
It's fine. You can call them petrol stations. You're in.
Not that anyone uses petrol anymore. But that was crazy to see, because it was almost like, I remember us having a petrol shortage in the UK about 20 years ago, and it was like, society breakdown.
Yes. The
queues at the pubs, and so you sort of think, wow, that's one supplier of fuel. It's
one supplier.
Yeah.
It then sparks a buy-off panic, because that's really what happened. The supply was not actually bad. The supply was not down. There was plenty of supply available, but it triggered a panic that you were not going to be able to get gas. So people pulled into the petrol/gas stations, depending on what side of the pond you're on, and started filling tanks and grocery bags and all sorts of things with gasoline, like all because of a ransomware attack. Had nothing to do with the gas pumps, but it sparked a panic that caused a shortage. And I think that's sort of the thing that we kind of need to dive into here is, Neil, we got to talk about the big elephant in the room here. Ransomware. And ransomware is kind of a problem for a lot of people, right? And I don't necessarily think that it's not something that you need to not worry about, because you won't be targeted, because we've seen businesses in every vertical. We've seen businesses of every size get hit. We've seen small municipalities like Lake City, Florida, got hit for like a $400 million ransom, which was just a spectacular, $460,000, not million, thousands, $400,000+ ransom. They're this big. They just paid the ransom and moved on because they're like, we cannot recover. Now let's talk about how we can actually help things recover and how to protect that data here. So it starts again with our servers. And our servers are our main, again, our primary storage. They live in our data centers and they're hosting our applications. And at some point, we're backing up to something. This could be, we're just going to pick disk here and make this our main backup data. Now, when we're talking about ransomware attacks, it's not just that they're going after your file data. It's not just that they're going after your main systems. They're trying to get as much as they can under ransom. And I think a lot of that comes back to making it as hard as it can to actually be able to recover. It's not a simple process to actually go do that recovery. It's actually quite difficult. So how does Object play into that?
Well, yeah, and let me say, I mean, to reiterate that point, I think the hackers have got very sophisticated in that they don't, if they find your primary file storage, they don't immediately try to encrypt that. What they then try to do is encrypt the backup data first, and then attack the primary storage, because you're more likely to notice the primary storage being unavailable because you're trying to work with it every all day, every day,
all the time.
Yeah. How often do you do a recovery from backup? Hopefully not very often. And certainly, most people don't, check their backups just because it's a big job. I mean, you should. Apologies to those that do, but we should be trying a recovery out, a random recovery at least once a week, I would argue. So yeah, they go for the backup first. So once they've got that encrypted, then they go after the primary and start to take that away. So at that point now, an organization has lost both their primary and secondary copy. So ultimately what we've got to try and do is to stop, that encryption happening. So of course we could talk all day long about all your different perimeter defenses, right? It's, there's a whole, huge industry around security perimeter defenses. But the reality is that most hacks these days are down to social manipulation. It's phishing attacks, it's getting information from people about, what their username and password is. So it's almost like the hackers are getting access as if they were a local user. And then it boils down to credentials. What can damage that user do? So there's lots of things to talk about that. And obviously what you can do to try and protect infiltration. But ultimately, you can have the best perimeter defenses in the world. If you've got a disgruntled employee and it's an admin, they can do whatever they want.
And
so
I think this plays into,
you've been out the window.
Object storage is not an end all be all, and this is the exact way that you can recover from anything. And this is kind of sort of this overall sort of play around ransomware and security in depth, right? Yeah. And by the way, cheap plug here, join us in September where we're going to talk a lot about ransomware. In fact, we're going to do an entire series on it, which is going to be fantastic. And Cloudian storage is going to be a part of it in terms of the overall story. But I think going all the way into you have this, nice perimeter level. I like to call, a lot of organizations have candy bar security or chocolate bar security, real solid outside, very chewy in the middle. And so the moment you get past that external layer, whether that's a spear phishing attack, someone clicks a link. In fact, we're in the middle of doing all of our information security training internally at Expedient that we do every year. And there's an entire course on phishing awareness of how do you detect a bad email? How do you make sure that you don't click the link? How do you, see all of the signs? Because sometimes they're real easy to see and sometimes they're not. Sometimes they're actually quite difficult to see. So being able to understand all of this in depth is really, really important. But when it comes to object storage, Neil, how does Object actually protect that data, right? Because we've got this primary copy, we've got this backup copy.
Yeah. So I think ultimately the question is not, if you're going to get a ransomware attack, it's when, because no matter what you put in on the defense side, it's going to be very difficult to protect against. And we look at some of the organizations that have been hit. I mean, they're not Mickey Mouse companies. They're serious organizations that spend money in this area. So with that sort of premise in mind, ultimately, the antidote to ransomware is you lock your data, that it cannot be modified. So essentially, we have this capability called Object Lock, which is part of the S3 API spec, so that when your backup application writes the data to the S3 bucket, it puts a period of retention on it, and it says in this time it cannot be modified. If anybody tries to modify it, if a rogue actor comes in and bypasses the Veeam process, if somebody gets access to the the S3 bucket and starts to delete stuff, what the system will do is it will process that, right? Because that might be a valid thing, but it would actually create a new version, or let's say the old object is versioned off, and then the deleted version or the modified version is what's seen kind of from the user perspective. But for the application, it's tagged that original data object with a specific version as well. So not only can it not be modified, Veeam or Rubrik or whoever's doing this, I don't, there are other backup vendors available.
Plenty of vendors, and they were all on that last slide.
Yeah. I mentioned Veeam because we've been doing a lot of work with them around this, so that was top of mind. But yeah, they will object lock and put that retention at the object level. So now we're not locking everything for the same retention period. It is very, very focused. So now we can say we want this object is going to be in a seven-day retention, grandfather, father, son type rotation policy. But this data is going to last for 7 years. So we can lock them at different levels, right down at the object level. So that's great, right? We've got the data is secured, you can't change it. Now, the next piece that we've been looking at as an organization is the security of the platform. Because no matter if you can get root access to any Linux machine, you can go down and delete. It doesn't matter at what level the application's working at. You get root access, you can go and delete. So basically, we've created a secure shell. And we've got, some, very significant US Fed certifications like, FIPS for the cryptographic module, common criteria. We applied to the Sarbanes-Oxley Security Commission Sec 17A for immutability. So we basically locked down, so you can't get root access, you can't get, any access to that data at all. And basically that data is there until you either take a sledgehammer to the system or the data expires.
I hope I don't have to take a sledgehammer to the system. I really don't want to do that. But I think
now we are supposing that an organization does have physical security that is going to protect the physical nature of the storage platform. There's nothing we can do about that. We can play our part in looking after the data, but then it's up to everybody else, the owner of that platform, to make sure that people can't just wander in and take disks out or sledgehammer it.
And I think the other key thing here is that all of the access is API driven. It's not user account driven. You can't phish the API key. The API key is baked in. So we have this ability to, again, protect the access layer and segment the user account access from this phishing attack getting to an API key that can get into the bucket. And even us inside of Expedient, we don't have access to the bucket. You have to go through the API key to get there. I do want to talk about one additional use case, which I find very, very fun before we take some questions here and wrap up. And that is file storage. And the funny part about file storage is that we haven't talked about file storage. We've been talking all about object and how file can't do these things and how SMP and NFS isn't built for the internet. And all of that is very true. But I think one of the key things that we kind of see is, when we think about how file storage is accessed, Neil mentioned it earlier, it's very single point. It's very lock driven, right? If someone opens a file, someone else can't open that file, or else the file system has no idea who made the changes. And so we wanted to be able to provide a way to do file storage in a ton of different places without having to have a file system array all over the place. We're trying to run individual cloud platform file systems. So we actually started with Object, of all things. And one of the things we did with Object, I just made that bucket very small. Now I can't make it bigger. Well, we'll just move it here. And then we'll put another bucket. We'll make this one small too. And we'll make another bucket. And now I've got 3 buckets because, as Neil mentioned earlier, we're just dancing at this point. at this point, I have 3 different data centers, right? I have data center, this is our Columbus data center, this is our Pittsburgh data center, and this is our Cleveland data center. So now I've got 3 data centers with this object platform effectively clouded off. So now I have one global file, one global object storage platform. Now, why is this important? Well, because I have to access this file storage from everywhere, I need a way to access that because object storage doesn't have a file system. So now I can drop servers, just you, make you small. I can take why is it not turning? There. Anyways, I have my on-prem environment. Now, in order for this to get its files, it connects back to the object platform. We create an object bucket. What does that actually give us? That gives us a canonical copy of the file. Now, why is a canonical copy important? It means I have one central place for this data to live, and it's replicated across those 3 nodes using Cloudian's data protection platform. So I don't have to worry about any one particular data center being completely offline and my object storage going with it. I can actually make sure that it's highly available and durable. And because I have this on-prem platform, I can maybe have 2 on-prem platforms. And I'm doing this left-handed, and that's why they're all tilting. But I can have maybe my on-prem platform, but this is my accounting. And this is an on-prem platform that is my engineering. My engineering group and my accounting group have different data. And because everything is connecting back and replicating back and forth between the filers that are on-prem and the object storage in the back end, I'm able to deliver file services anywhere. And I can make it very customized to what is actually living in these on-prem environments. So my accounting group, whole lot of XLS, whole lot of Excel spreadsheets, QuickBooks, accounting system data. But my on-prem engineers, they've got CAD and they've got images. Those are 2 very different data types, and I can customize my caching based on what they need, and I'm only keeping the local storage set to what those individual groups need. So my accounting group may not need a super huge cache because Excel files are real small, but my engineering group may need a very large cache because CAD files and image files are very big, and I can customize it as I need. But I can also drop this into, here we go. I can drop this into my enterprise cloud. So if you're inside of our environment, you can utilize our file system and our file servers to eliminate all of the migration and all of the headaches that you have with your file services and keep it in one canonical place and make it available in our cloud or in any of your on-prem locations. And that's all fun and games until we get to the last use case, which is where I go into my hyperscale clouds. Because when we think about these hyperscale clouds have a number of different opportunities for file services access, right? You have an application that writes out reports. You have an application that needs to access logs. You have an application that just needs to write to file services at some point. Where does that go? If you're writing from your application in a hyperscale cloud back to on-prem, you're generating a ton of egress fees and spending a ton of money doing the same thing you were doing before. With this, I can land the filer inside of that platform, eliminate all of the egress fees, and have a canonical location and replication that happens between my filer and my global cloud storage platform. It creates this massive capability. When I'm referencing on-prem, am I talking an on-prem Cloudian appliance? No, in this case, I'm actually talking about a virtual appliance from a partner vendor of Cloudian. It's Cetera. They actually showed up on the thing, and I kind of put my mouse under them. But Cetera actually allows us to deploy these virtual appliances anywhere they need to be. But because we have Cloudian's object storage platform on the back end, the individual Cetera platforms don't need to have anything. They're just caching appliances. And it gives us this massively flexible and massively scalable file storage platform without having to put a ton of effort forward on the client side or even for us. And Neil, I cannot thank you guys enough for creating this really great object platform to enable these other use cases that we have, right?
I think it gives, the world's gone S3. AWS has been very successful, and I think one of the things we can do is working with the likes of Expedient is to provide an alternative to AWS. It's never good to have a monopoly in the market.
Nope.
And I think some of the other things we've been talking about, we can add further use cases to it as well.
So let's dive into a couple questions here before we wrap up. The first question that I have here is, what does the recovery workflow look like in this situation? Let's see if it updates. It did. Amazing. Technology is great, isn't it? So what does the recovery workflow look like? So your object storage platform here has that data stored in it. Your backup platform that lives on-prem in your environment, so whether that's Veeam, Rubrik, Cohesity, Commvault, Tivoli, IBM Spectrum Protect, all of the lists. I'm probably forgetting somebody, but I'm forgetting a bunch actually, probably. But that platform would have access to the object platform. So when you need to recover, it will go into the object platform, just like it would know that, this tape set from 3 weeks ago had that data. It would go into the object platform and pull that back in. In the case of ransomware, it's the same sort of thing. You would need to recover your backup platform, but your data would all be stored securely, and you would still be able to get that data back from the object platform inside of Expedient's Cloud or Cloud Object Storage. And the last question that we have here, can you recover to vCenter VCD? Yes, that is based on the actual backup platform that you're using. So we are working on our integration to the object platform for that backup. That is something that we're working on and investigating, because we definitely want to make that possible, especially given companies who have longer retention times. As Neil mentioned, retention is kind of a thing. And so we want to make sure that we can provide the best storage platform possible. So we have ways to do that, but the backup platform is the front end. It's a weird thing to say, backup is the front end, but the backup platform is the front end to do the recoveries back into vCenter and to VCD. Neil, thank you so much. This has been fantastic. I hope everybody enjoyed these whiteboard things. We have one more question here. If we're backing up our Oracle databases to Commvault, should we be switching to object storage? I think object storage is definitely a part of that. It is not the whole story, but it is definitely a major part of it, especially when we think of the whole 3-2-1 backup scenario. It's definitely something to consider. We can definitely talk about how we land that on an object platform. We've talked to customers about backing up databases to our platform, or backing that up into an object archive. So we're working on that as well. So there's definitely things to talk about there, and dive more into your use case, how often you back up, your speed and connectivity to data centers, those sorts of things.
And I would just say, if you're wanting ransomware protection on that database, yes.
Yes.
Although I might be biased.
Neil can be as biased as he'd like to, because he works for he works for Cloudian. How secure are the API keys? So API keys are very specific. They have very long secrets attached to them. They're usually not guessable. In fact, they're never guessable. It's the whole point of an API key. It is stored into your backup platform. So it is not something that somebody is going to access. They're just going to encrypt the data, but they would still need to access the backup platform itself to get to the API key. And even then, the secret is stored in a secure fashion in your backup platform. API keys make this super simple, and make it easy to lock down the access to only what is needed. Again, least privileged access, we love to see it. So by having that API key, and by having the API key in that process, it makes it easier to protect that data. I do want to thank Neil, a quick behind the scenes. We started late because Neil could not get on because Zoom was not liking the fact that he was coming in from the UK. We're not entirely sure why. But Neil made it work, and we're super glad to have him here. If you have any questions, you can reach out to me, aj.kuftic@expedient.com. Neil, do you want to hand out your email address or contact information here?
Yeah, nstobart@cloudian.com.
There's the spelling of Neil's name. We'll go back one slide. So nstobart@cloudian.com.
Yeah.
Reach out to Neil. You can reach out to me to dive deeper into cloud object storage. Thank you so much for joining. Please join us August 12th, where our experts at Expedient are going to take over. I'm going to do less talking. They're going to do more talking, where we talk about how to secure cloud, or how to spend $300,000 without really trying. We look forward to seeing you there. Thank you so much for joining us.
Thanks, guys. Thanks for your time.